In lesson 6.5, we are going to learn how to graph linear inequalities. And what we're going to use is we're going to be using a coordinate plane. All right, what we have been doing is we've been graphing inequalities using a number line. So we used an open and closed circle and shaded whichever direction it should be. But in this lesson, we're going to be using a coordinate plane. Now, I will always tell you what I want you to graph on. So don't ever think it's going to be like, well, how do I know which one I need to graph on, a number line or a coordinate plane? The directions will always say graph on a number line, graph on a coordinate plane, so you know exactly where to graph, okay? But before we get into all that, we're going to brush up on our seeing if the ordered pair is a solution to the inequality. So they've given us 3 ordered pairs. Remember, an ordered pair is always listed x, comma, y, and they've given me an equation here. They want me to plug it in and see will it be a solution. So I'm going to do 4 times negative 3 plus 5 times 5 is less than or equal to 12. So all I did was take out the x and plug in the negative 3. Take out the y and plug in the 5. Okay? 4 times negative 3 is negative 12 plus 25 is less than or equal to 12. So I'm going to have 13 is less than or equal to 12. Is that a solution? Is 13 less than or equal to 12? No. Okay, let's try the next one. 4 times 0 plus 5 times 2 is less than or equal to 12. 4 times 0 is 0, so I can say 5 times 2 is 10. 10 is less than or equal to 12. Is that a solution? Yes, it is. Alright, and let's try the last one. 4 times 6 plus 5 times negative 8 is less than or equal to 12. 4 times 6 is 24. 5 times negative 8 is negative 40 is less than or equal to 12. 24 minus 40 is negative 16 is less than or equal to 12. Is negative 16 less than or equal to 12? Yes, it is. So this would be a solution. So basically all we're doing is figuring out is the ordered pair solution, plugging it in for x and plugging it in for y. Now, we're going to go ahead and start graphing. Now, what they want us to do is they want us to graph the inequality using a coordinate plane. See how I have clearly specified what I want you to graph it on. Now, if you remember, a coordinate plane means I have a y-axis and an x-axis. You may say, well, how am I going to graph x is less than negative 2 on a coordinate plane? I'll show you. Okay, first of all, there are some things you need to know. Whenever you have a less than or greater than sign, when you graph on a coordinate plane, you're always going to use a dotted line. Whenever you have a less than or equal to, greater than or equal to, you're going to graph using a solid line. The easiest way to remember this is if it has a solid line underneath the sign, you use a solid line. If it doesn't, you use a dotted line. So just remember how we did the open circles and closed circles. It's the same exact type thing, but this time when we graph on a coordinate plane, we always have lines. We never have any circles. So we're going to use a dotted line if it's less than or greater than, and a solid line if it's greater than or equal to, less than or equal to. All right, so what they want us to do is they want us to graph x is less than negative 2. Anytime they only have one variable here, they're talking specifically about the x-axis. So I'm just going to draw a coordinate plane instead of getting out my graph paper and doing all that. Now, we will have to do that in a minute, but for right now, we're just going to draw our graph. I'm going to write 1, 2, 3, 4. Okay, this is my x-axis, this is my y-axis. So they're telling me on the y-axis, on the x-axis, that's what that x means right there, it's going to be less than negative 2. So what I do is I go to the x-axis and I find negative 2. It's right there. What they want me to do is they want me to draw a line through that. Now, not directly through the x-axis just like that, but it has to basically pierce the x-axis is what I like to say. Well, since it's a less than, I know it's got to be a dotted line so it has to go straight through the x-axis. Now you say, okay, what does the less than sign mean? It means I have to shade in the direction on the x-axis. I only look at the x-axis because that's what variable they gave me, that the numbers are going smaller than -2. Well, I look and I say, okay, -3, -4, this is the way that the numbers are going smaller. So I would shade all the way down my coordinate plane. And that's exactly how you would graph that. Okay? Now let's do the same thing, but let's do the next one. That's all you would do in order to graph it. Okay? We've got x is greater than or equal to -1. So what axis am I looking at? The x-axis only, because that's the only variable they gave me. I find 1 on the x-axis, which is right here. Okay? And am I going to have a dotted line or a solid line? Well, here's a solid line underneath it, so I want a solid line through the one on the x-axis. So I would draw it straight down. Okay? And I want to shade where x is greater than 1. So I know x has got to be going in the direction, or the shading has got to be going in the direction where all the numbers on the x-axis are getting bigger than 1, which is everything over to this side. Okay, you may say, but look, it's touching the negative numbers for the y. It does not matter because x is the only axis I'm looking at because that's the only variable they gave me. Okay, so that's how we'd graph on a coordinate plane when they give us just one variable. Now let's try it with these problems. Okay, again, I've specified I want it on a coordinate plane. So I'm going to draw my coordinate plane here. -1, -2, -3, -4, -5. Okay, now look at what variable we have this time. We have a y, okay? So what axis do you think I'm going to look at? The y-axis. Last time when they gave us an x, we only looked at the x-axis. This time they gave us a y, so we're only going to look at the y-axis. And I'm going to change my color here so it might be easier to see. So I look at my y-axis only, and I need to find -3 on the y-axis. It's right here, okay? Am I going to have a dotted line or a solid line through that -3? It's going to be a dotted because it's just a greater than sign. Okay, and now I need to look at my y-axis only. It's y is greater than -3. So I'm looking at all these numbers here and I say, okay, in which direction, above the line or below the line, are the numbers going greater than -3? Above it. So I'm going to shade everything above the line that I've drawn. And you say, well, hold on, it's touching all of those negative numbers on the x-axis. Doesn't matter. The y-axis is the only thing I'm looking at. Okay? So let's do the next one, which is y is less than or equal to 1. So I find 1 on the y-axis, which is here, and it's less than or equal to. So I'm going to have a solid line that goes directly through the y-axis at 1. And then I ask myself, okay, looking at the y-axis only, which way are the numbers going less than? Down. So I need to shade everything below the line. Okay, and that's exactly how you would do it whenever you have a variable that's just y. Now, look at what they give us in example 3. They give us, it's supposed to say example 3, not example 2. They give us an x and a y, okay? These are just like graphing a regular equation. In order to graph that equation, it's got to be in y equals mx plus b form. Even if there's an inequality sign, I leave it just like it is, and I would do y is greater than or equal to mx plus b. So I've got to get y by itself, so I have to subtract 1x first, and I get y is greater than -1x plus 3. I'm going to graph my line just like this. I no longer am just looking at the x-axis or just looking at the y-axis because now I've got two variables. So I am going to use a piece of graph paper for this. Okay? I'm going to erase some of this stuff that I have up here. I'm going to rewrite it. Y is greater than negative 1x plus 3. Now I'm going to draw my graph here. This is my y-axis and my x-axis. This is okay, so I'm going to specify x-axis, y-axis. Now, I graph this just like I would a regular line. So, I know my m and my b. So, what am I going to graph first? The b. I know that b is equal to 3, because here it is right here, my y-intercept. So, I go to 3 on my y-axis. Now, I'm not going to draw a line straight through it, because I still got to use my slope, which is m is negative 1 over 1. So, I go down 1 and over 1. And this is where the lines come in. I've got to decide, do I need a dotted line or a solid line? I look at my sign here, and it's greater than, so I know I need a dotted line. Now, this is where the tricky part comes comes into play, because you've got to figure out, where do I shade? Because y is over here by itself, I always look at the y-axis when it comes time to shade. If it says y is greater than, I'm always going to shade looking at the y-axis, which direction the numbers are going bigger on the y-axis. Well, that's always going to be going up. So anytime it's y is greater than, I always shade above the line. Okay? Alright, so that's exactly how I would shade that example right there. Okay, now let's do the next one. Okay, do another one. First of all, I've got to get it in y equals mx plus b form first. So I've got to move the x. Well, what's the number in front of x? Well, it's 1. It's a positive 1, so I subtract 1x on both sides. But I'm still left with negative y is less than or equal to negative 1x plus 2. So I've got to divide everything by negative 1. What happens when I divide by a negative answer? I have to flip my sign. So I have y is greater than or equal to 1x minus 2. Now I can graph my line. So I go back to my coordinate plane. Okay. I have my x-axis and my y-axis. Alright, and so what I want to do here is I want to graph my line. Okay, first of all, I know my b is negative 2, so I'm going to go to my y-axis and go to negative 2. Then my slope is 1 over 1, so I'm going to go up 1 over 1. Am I going to have a dotted line or a solid line? So I look to my sign, and it's greater than or equal to, so I know it has to be a solid line. It's going to go through my points, and I have to figure out where I need to shade. Well, it's y is greater than. So look at my y-axis. Which direction are the numbers going greater than? Above, so I shade everything above my line. And you always want to shade because an inequality means that it's not just one answer. It's when it's y is greater than. So it can be any number that is greater than, let's say 2, if we would work all this out and get 2. So I would have to say that it could be 3, 4, 5, all the way up to 1,000,000 if I needed to. So that's why you shade and not just leave a line there. Okay, so that's how we solve graphing with inequalities.